A geometry benchmark 8.2, area of regular polygons. Find the area of a regular undecagon with a side length of 12 feet. I'm not going to try to draw this accurately, but it's going to have a bunch of sides, and you need to find this triangle here. You need to find the height and the base. If we know the height and the base, and we could figure out the area of this piece and then multiply it times 11 of those triangles inside of there. So if I just draw a bigger version of that, and the information we have is 12 feet for the side length, well, that makes this the 12 down here. So we can break this into a little triangle and make that 6. So I'm just going to keep making that bigger here, this piece. And all I need to do is find the height with the information I have. Well, an undecagon has 11 sides, so it's going to have 11 triangles going around the center there. So if I take my 360 and divide it into 11 parts, I'll get 32 on my calculator, 32 point something. And I'm going to divide that by 2, and I'm going to get an angle in here of 16.36 repeating degrees for that one angle right there. If I put an x there, I can figure out using trigonometry. I'll use tangent. I can figure out the height of that triangle. So if I use tangent of 16.36 repeating degree, I'm going to keep that decimal repeating just so it's more accurate, equals the opposite side, 6 over the adjacent side, x. And the shortcut that I use, I just divide right divided by left. So if I type in 6 divided by tangent of 16.36, I'll get a height of approximately 20.43, and it goes on for a while. So a little over 20 feet tall. And then to find the area of that triangle then, let's stick with this triangle here. I'll just take that 20 that's already in my calculator, I'll multiply it times 6, and then divide by 2 because it's a triangle. And I'll get my answer, and then I'm going to go times 2 to get this triangle, the other half of that triangle along with it. So it's kind of confusing when you divide by 2 and times 2. You could just plain go this 20 up and down here times this 6, and I'll be done with it, and that gives you this whole area down here. But just to keep it straight in my head, I just go the 20 times the 6 divided by 2 gives me the area of that triangle, and then double it to get the area of that piece right there, which is going to be the original piece I was looking for down here. And when I get through all that, I get about 122.6, and keep that number in your calculator. And then that's one triangle, and I know I have 11 of these triangles going around. So multiply that times 11 for your final answer. And that should be somewhere around 1348.7. Now is where I'm going to round this. Square feet. Don't forget your units. I have 2 more here for you. So one, I gave you the side length. If, by the way, I'll go back to that problem. If I don't give you a side length, maybe I'm going to give you the perimeter. Okay. If I do give you the perimeter instead, like on a test or something, or even on a benchmark, just take that perimeter, divide that into 11 parts, and then you get each one of these parts, each one of these sides. And that's just like doing this problem then when you have that 12. So I could give you a side length, I could give you a radius, I could give you the apothem, which is the height in the inside of that shape. So here, a hexagon I can draw, and a radius means to the corner here, because you're imagining a circle going around here, and a circle's radius is right there. So you visualize that. So I give you the radius is 10, and then you just need to find that height. We'll do the same process. We need the base, we need the height, and if we do base times height divided by 2, we can find this thing. Or if we do half of the triangle, this is what I'm probably going to do. So let's start with that half of that triangle. This is 10. With this 360 all the way around, it's a hexagon, so it's got 6 sides, and which means it also has 6 triangles inside of here. Okay, 1, 2, 3, 4, 5, 6. Okay, so I can figure out this angle right here, which is half of this. So I'm looking for this angle right here. That's going to be 60 degrees. Well, if that's 60 degrees, it's just like working with special triangles. This is going to be 30 degrees. Okay, so I'm just taking half of it. I'm looking at this triangle. Okay, that's this. And if that's 30, I could just use special triangle concepts and just take the 10, cut it in half. That's 5. And this is 5 square roots of 3. Or you could, again, use the trigonometry. And could just call this, we're looking for the base and the height. But I'm just going to let's start with the height. If this is 30 degrees and this is 10, then I would use cosine, because these two sides are close for cos, or we have the hypotenuse and we have the adjacent side. So cosine 30 equals the adjacent over the hypotenuse, so x over 10. And when you multiply those two together, we'll get the same answer. We'll get the decimal version of that. I think that's 8.66. And to find the bottom part, we could use sine. We could put, let's call this, I don't know, y. And say we have, no, ignore this. Now we have the sine of y, or sine of 30, equals the side opposite over the hypotenuse. When I cross multiply here, I'll just get that 5. Okay, well, that's a lot more work. That's why I'd rather do special triangles, because we got there a lot faster before. So get rid of this. Let's get rid of all this stuff. All right. So we have our triangle. Now we just do base times height divided by 2. So 5 times 8.66 divided by 2. And we get the area of this. And then I'm going to double it to get the area of this whole big triangle in here. So 5 square roots of 3 are 8.66, and again, I'd like to keep more decimals in here. In this particular problem, it doesn't really affect the answer. But 8.66, let's say, times 5 divided by 2 gives me this triangle. Double it for the whole thing, and then multiply that by 6. 1, 2, 3, 4, 5, 6 of those. And that turns out to be 259.8 square centimeters. All right. And then one more. A regular decagon with an apothem of 20 inches. So without really trying to draw this too accurately, the apothem is that straight up and down side. Okay, so when I have this triangle blowing up here, this whole thing, the apothem is this piece right here. That's 20. So all I really need to do is find the base, because I have the height, which is of this triangle, which is the apothem of the shape, and it's just base times height divided by 2, and I get the whole triangle. So I take my 360 here, I'm going to divide it by 10, because decagon has 10 sides, which means there's 10 triangles coming inside of here. And that'll give me 36 degrees for this whole thing. So if I just take half of that, break it down so it's a little bit easier, that's only going to be 18 degrees. I know the height of that triangle then is 20, and I just need to find x. Well, that's tangent again, because we're dealing with the two legs. So tangent of 18 is x over 20. And when I cross multiply that, I get somewhere around, where is it, 6.498. All this stuff's on your calculator. So this base is somewhere around 6.5. And again, try to keep those decimals in there. And then just do this base, so that's 6.498, that's in your calculator, times 20, divide by 2, and you'll find the area of that triangle, times 2, to get the area of this whole triangle here. And then that turns out to be, for this whole triangle here, somewhere around 129.9, blah, 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 blah. So that's this whole triangle here. Looking back at the original problem, we have 10 of those. 1, 2, 3, 4, 5, 6, all the way around. 10 of those triangles inside the original shape. So just take that 129.9, go times 10, which basically just means move the decimal to the right a spot, and you get 1299. Rounded at the nearest tenth is 0.7 square inches. Okay, went through those pretty quick, but you've seen all the possibilities that I could ask you. I could give you the perimeter. I could give you the perimeter of the original shape or a side length. Okay, side length is easier. Perimeter, you just have to divide into 11 parts or however many parts we have, and then go through this process. I could give you uh, the radius, so going from the center to a vertex, or I could give you the apothem, which is going from the center straight down to the middle of that bottom. So 3 different types of problems. The processes are all basically the same, but you just have to find different parts.